You've just had assignment 1 released last week, is that right? How's that going? It's fine? What's wrong?
Can I swap you?
John.
Sorry.
John. Oh, is it not on?
Yeah.
Did I just not turn it on?
That one should work.
Why is that coming through? Do you have to mute something? Hello? Hello? Input. How's that? Hello? No, so where's the sound coming from? Sorry? The little puck. I think you just got it. Hello? Okay, that's gone. No, it's not gone? It's fixed. And can they hear me in the room? Yeah, and can they hear me online? All right, sorry about that, everyone. Okay, I must commend you on the turnout for week 5. That's really good. Okay, so we've wasted a bit of time, so let's get going. All right, so what are we talking about today? We're introducing a new concept, command line arguments. All right, we're going to do a demonstration of assignment adjacent code. So I will be writing a C program that should resemble quite closely what you're expected to deliver in terms of assignment 1. And then supposedly, if we have time, we will discuss multi-file projects. Maybe we won't get time to do it properly, but we can just introduce the idea of it. It's not really a core concept for COMP1511. All right, sound good? All right, we're going to have fun. Okay, I don't care what you did last week. I've already hooked up my live lecture code to the course repository, so it should work the same way you're used to. Yep, let me know if there's any issues. All right, command line arguments. Can someone yell what is a, oh my God, this drawer. Can someone yell to me what a parameter to a function does, right? This is something you should all know, right? So you have functions in C, yes? Yes, yes, yes. What's a parameter to a function?
A parameter is an input value that's passed down to a function so that it could potentially manipulate it.
So let me repeat so you can hear me online and in the room. A parameter is input into a function. I'll summarize for you. Everyone agree? Thumbs up if you agree, or hands up if you agree. Anyone disagree? Who gets parameters? Like gets the idea of them and why they're useful? Okay, anyone not get them? Okay, so you're either shy or not confident. So parameters are important because when we do certain things, and it doesn't matter if these are things in programs or if they're things in life, right? Like if I tell you to go shut the door, what do you need to know? Well, I didn't ask you.
Oh, I heard it generally.
No, you in particular. If I say go shut the door, what do you got to say? Which door? Which door? Some imperatives need extra context. The action of shutting a door requires to know which door we're talking about. And just in that same way, functions need parameters. So if I've got a function multiply by 2, what do you need to know? The number that we need to multiply by 2. Exactly, and that would be the parameter, the input into a function. Just like functions have parameters and input, okay, programs can have input. So that idea of passing detail or context into an action, parameter, we can apply that exact same concept at the program level. You do this all the time already. So who's familiar with the make_dir command on the command line? So what does the command do? Makes a new directory. And what does it need to know? The name of the directory. And how do you pass that context to the make_dir command? Well, just think about it. If you're on the command line, clear that. Let me go to my desktop. Can you all see that okay? Yes? If I want to make a directory here, what do I type? Make_dir. And how do I tell it the name of the directory I want to make? I hit space and then I type the name, Jake. And then when I print everything in that directory, we see that Jake directory right there. So make_dir is a program. Just like the programs you've been compiling, right? When you write your assignment code, you write a lab code, you compile your C code, you produce an executable. That executable, you execute it in the command line. I'm executing a program here. The program is called the make_dir program. Now, it's not a C program, probably. It was probably a different type of program, but it doesn't matter. And if I need, some programs need input. And the way we pass those is space-separated lists of text. Can you think of a command like make_dir that has more than one input? Okay, that's a good example, actually. I wasn't thinking that, but the student here said DCC. That's a great example. So DCC is a program. The compiler is a program. And actually, think about DCC. It's very complex because it doesn't always have, like make_dir pretty much always has one parameter, one input. But DCC can have a variable range of things that go into it. So that's a complex example. Do you have a simpler example or another example? Yeah, so the code command is one where you can give it file names or a directory or multiple file names. I was thinking copy, the CP command, right? You copy one thing to another thing. So that one has 2 arguments. So we're used to this idea, right? This is not a new idea. Command line arguments. We want to sometimes create programs that are launched with some context, with some arguments. Now, something just to note conceptually is that that context is provided when the program is launched. So it's like when you launch that program, you can give it arguments, but not any later. Does that sort of make sense? So it's when you create the program, you can give it some arguments. Now, so who's comfortable with the concept? Just the idea. Forget about what code and... okay. Okay, so that means everyone else is not comfortable. Is that right? So who's not comfortable? Okay, you're all like zombies. Who's comfortable with the concept I just introduced? Okay, and who's not comfortable? All right, then I'm going to take this move, but Brianna's not comfortable. All right. So now the question, what's the question? What's the next question? Did someone answer? Well, how do we do this? How do we create programs that allow this? And that's what we're talking about here. So I said earlier that these arguments are passed to the program when? At what point? You guys are killers. When do we launch these? When do we pass these arguments to the program? Who spoke? What did you say? While running it, can you get a bit more precise? When we start the program. Yeah, okay, that's it. When we start the program. So when we're writing C programs, where do we start the C program? So I mean in the code. In main, fantastic. So main is the entry point to our programs. So that must give us a hint as to where we can go about supporting command line arguments. And as this slide is showing here, we modify main such that we collect the potential arguments. All right, so let's open up some code. I think so far Angela's been working in VLab. I'm not going to do that, so I don't know, deal with it. Public (25t1). Let's go code arguments.c. Oh, that's got a typo there. Did that not work? Is dark mode or light mode better for the lecture? Dark? Oh, that's complete code, so we don't want that. All right, does that look right? Does this look familiar to everyone? Yes? All right. So main is the entry point to our program. At the moment, the main function has a parameter of, or an argument of void. So what we're saying is we don't expect anything to come into the entry point of the function. Right? However, the arguments can and are passed to the entry point of C of programs, so main. So just like we pass parameters to functions in C, we can pass arguments or parameters to the functions, to the function main. So how do we do that? Let's have a look at the slides. We change void, now copying this probably won't work, to look something like this. right? And we're going to break it down. So rather than main accepting void or nothing, we expect something to come in. So how many parameters are there to the main function here? 2. What's the first one? An integer, so the type is integer. What's the name of it? Argc. Any guesses as to what that stands for? Argument C. Well, we can be closer. Argument count. Argc tells us how many things were passed when this program was called. How do you think the operating system might know how many things are passed in? So just think about it. Let's go back to a terminal here. And let's say I'm using the copy command and I give it, input A, input B. If you just look at this with your eyeballs, how many things are being passed? Someone said 3, which is actually correct. But for all intents and purposes, 2 things, A and B. And how do we know that they're separate things? Because there's a space character between them. So the operating system's actually counting, hey, we called this program called CP, and there was then there was 2 things that came after it. So argc will get told somehow that there's 2 things to expect here. So argc exists so that you know what to expect in argv. So what do we think argv represents? Argument variable is incorrect. Someone said it correctly here. Was it you? Argument vector. Who knows what a vector is from mathematics? Oh, you can yell it. A list. A list. It's the list of arguments. Now, if we were in a nice, modern... Actually, let me rephrase this. If we were at a worse university like UCID, and you did your intro programming course in Python, we wouldn't have this problem where we need argc and argv. We would just get a list of input. And in Python, lists are quite dynamic, so they can actually tell you how many things are in them. Okay, but we don't have that luxury because we made better choices. So C can't do that. There's actually no such thing as a vector data structure built into C, so we have to get creative. And what we do here is we say, well, I can't give you a list of things, so I give you a count, and then I give you the things, and it's your job to put them together. Now, there's a few more things going on here. There's this funky asterisk, which I don't think we've discussed yet, correct? In this course? No, we haven't. That's fine, so I'm going to skip over it. And we got this thing here, which represents what? We haven't discussed that either? We have. You guys are just... What do the 2 empty square brackets usually mean? An array. So you can just basically think of this as an array. And we should know from arrays that they don't keep track of what? Their size. That's why we have argc. Is this making sense? And I'm just telling you for now, let's skip over that asterisk. It'll make more sense in about 2 weeks, 1 week. Yeah? Sorry? This week? Oh, this week, Wednesday. Cool. Good luck, Sasha. Good luck, you guys. Pointers are hard. So yeah, it is a pointer for anyone playing at home. All right, so with this small addition, right, main turning into this, we can now access the arguments. Who's, when they've been struggling through the assignment or their labs, they've Googled, what's that stupid website that comes up anytime you Google C? It's like Code Geeks or something. Geeks for Geeks or something. And who's looked at a C program there? You've probably seen this, yeah? Yes? No? You'll see this in many online examples because it's technically incorrect to put void there. Because C programs should expect input, even if we're not been using it so far. So this is actually the correct way to write a C program. All right, I just want to do something quickly here. Okay, and I want to close that. And I want to close that. And I want to go to slides. All right, so here it's all here. argc is the counter, argv is the array of different command line arguments. So let's compile this program. Now, because I'm working locally, I don't have DCC, so I'm just going to use GCC. It's the same idea. So GCC, let me save that, arguments underscore lecture, and I'll compile it into a program called program. And I run program. So that code compiled successfully. There's no errors. However, we're not doing anything with the program. When I ran this program, did I pass it any arguments? No. So if I run it again and I can pass it, hey, again, it worked, but nothing happened because our source code didn't do anything with those arguments. So let's do something with the arguments. Let's actually access the arguments. So how do we think we might do that? We got no idea? Well, let's look at the slides. Let's not look at the slide. Let's keep it a bit simpler. What is argv? It's an array. How do we access just the first element of an array? argv 0. Yeah, exactly. That would access that array at the 0th index, the first element. Well, no, none of this works because we've got to print it out. So we can print f. Now, what data type must this be? Don't tell me the formatter. What data type must it be? Good question. No, not a character. Not a pointer. A string. Yeah. We've done strings, right? Yeah, it's a string. If you think about it, what's this? What's this? It's a string. It's a string. The letter H is a character, but it would be kind of annoying to have to get every single character. So we can treat each argument in the argument vector as a string. In fact, anything in the terminal, absolutely everything in the terminal, it's all text. So it's all strings. That's how terminals work. So I want to do %s, comma argv, I think. I don't know. My format is probably a bit funky here. All right, let's recompile this. Let's rerun it. Now, let's give it the argument Jake. Okay, what got printed there? ./program. That's not what I wanted to print. We wanted to print the parameter Jake, the argument Jake. And that's where someone here said something, either they've looked ahead or they just know, that actually when you run a program, the operating system passes the name of the program that was executed as the first argument. So, but using that logic, if we want to access actually the first argument, what might we have to put in place of the 0? 1, exactly right. And then I get Jake. And we can make it a bit nicer by putting a \n there. Is that cool? So that's why I said earlier that all C programs always have arguments coming in, even if you don't actually pass anything in, because the name of the executable, it's not the name of the executable. It's not, what is it? Anyone want to know? It's not necessarily the name of the executable. Actually, no, it is the name of the executable. Well, it's the name that the user actually executed. So I could do something like symlink program to another name, and I would get the other name. It's useful sometimes. Anyway, I'm getting off topic. Get used to it. Is this making sense so far? Oh, guys, don't make me... Okay, good. Anyone lost? That's fine. That's life, I suppose. No, we'll keep going and you might start to get it. If not, you can ask questions. All right. Now, when I'm, oh yeah, question? Argument vector 0 is going to print, when I recompile it, the name that the user typed in to run the program.
So the space makes
So-
the points that the program and the J, the two.
Correct. So let's look at what I actually typed to run this program with the argument Jake. I typed program, ./program, and then I typed Jake. So 0 is ./program, 1 is Jake, and if there were more, it'd be 2, 3, 4, 5.
So every element needs to have a space between them.
The space, when we run our programs, is how the operating system knows on a Unix-based environment the separation of arguments to a program. That's correct. It's all about that space character there. Question?
Yeah, what if we like to print what if we actually want to print the space?
What if we want to print the space? Okay, I can answer that question. You can't, because the operating system doesn't, this is one long string here that gets sent to the terminal. The operating system processes it. It does something that we would call splitting it by the space character. So it gets rid of the spaces and creates a vector and gives that to the program. So you could put the space back, but you'd have to do it yourself. You'd have to print argv0 literal space, argv1 literal space, so on. Does that make sense? So that space character is not coming to us. Any more questions? Okay. Now, what this slide is getting at is something a little bit even more interesting. So in this case, I'm always printing either the 0th or the 1st or the 2nd argument. But when you write the code, do you know what the user is going to give you? No, we don't know. So this is not dynamic. We've hard-coded accessing. Now this can cause a problem. In fact, I don't actually know what will happen. But what if I don't give it an argument? We get an error. So this is pretty bad code. Agreed? So if only we had some way to know how many elements there were passed in. Argc. It's all about argc. What we typically do when we're processing arguments inputting to a program is we use a loop. So that's what this lecture code is showing. Do you like my spotlight? We loop how many times? argc times. And we use I to access each element in argv. It's a really simple idea, and it works. So should we type that out? Printing each argument. So what do we need to do? What do we need to do? We need to loop. Okay, so how do I write a loop? Sorry? Do we do while loops or for loops so far? We've done both, so I can do a for loop. Is that okay? Do I have your permission? How do I do this? That's what I did, right? This will loop how many times? argc times. And for each time it loops, instead of accessing argv at an index, as a literal index, what do I want to use to access it? I. Let's just see if this works. We might be off by 1 or something. Let's go Jake for now. Okay, printing each argument. I get program, I get Jake. If I run that again and I give it, hello? Is that what you said? Maybe not. Anyway, we get hello. If I run that again and I don't give it any argument, I just get program. So that seems to be doing a pretty good job. Now, if you were a more complex program like DCC, now you would have a lot more work to do, like to analyze the values, determine if it's a flag like -O. Then you've got to do stuff like, well, if I get a -O here, I need to look at the next argument and do something with that and save that somewhere. And you can imagine that pre-processing can get quite complex. But just so I can know and handle the input, this is doing a pretty good job. Yeah, we've done basically the exact same thing on this slide. Are there any questions? No? Who's happy? Okay, good. Don't complain later. All right. What did I say earlier about the terminal? Well, I said probably many things, but what's something important? Let me run another little demo. I run program, and I give it the number 5 as my input. Ooh. What's special about that number 5? Or maybe a better question is, what's not special about the number 5? You're saying it's an integer? Yeah. You're wrong. It's a character. It's the character that represents the integer 5. Everything in the terminal is a what? Characters or strings. That's right. I'm teasing you. Don't get offended. Everything's characters here. The terminal doesn't deal with numbers, types, ints, doubles. It means nothing to the terminal. It's all string. Can anyone have a stab at why? Huh? Ascii? Go even further, more fundamental. Who's gone into the K17 building? Oh God, that's not a good sign. Who has gone into the computer science building that you're sitting in right now? Okay. Who's been to the museum? Well, it's not really a museum, but who's seen the museum computers? 1 person, 2 people, 3 people, a few people. There was no terminals. Well, a terminal meant something very different a long time ago. The terminal would be a printer. So literally, there was no screens with early computers. So if you ran a program and the program produced output, what did it do to that output? It would literally print it on a printer, a matrix like a printer. You'd get a printout. So everything had to be text. And we've actually just sort of gone from there. So, and just still today, everything is text here. Okay, that was a history lesson that no one cared about. But what if I want... Okay, so here's the problem, right? So let's make a program. This program, I'm renaming it. Oh no. Okay, I'm renaming this to a program. It's going to be called doubler. So this program's going to be called doubler. It's going to take a number and double it. The whole program's going to do that. All right? So I'm not going to have this loop here. I'm going to say doubling %s. That's going to be argv1. Okay? And what I want to do is printf. Now it's %d, right? Is that right? \n, and I'm going to print out the value of argv brackets 1 multiplied by 2. What's wrong with that? Okay, well, yeah, it's spoiling my task. But does everyone get what I'm trying to do here? Yeah? In fact, this squiggle is a bit of a spoiler. It's warning me already that something might go wrong here. But let's just think about what I want to do. So I compile the program doubler out into something called doubler. Now I get an error here, but let's kind of just ignore it for now. I would run the program doubler, and I would give it the number 5. And I want it to output the number 10. But none of that will work. Why? Because 5 gets passed in as an argument of a string. Because the terminal is all strings. So who gets the problem? Okay, good. So what I need to do is be able to, at the right time, try and convert strings to integers or strings to doubles dynamically. Especially when we're dealing with command line arguments, because everything has to come in as a string. It's not like functions where we can pass things around as integers and doubles. So the way we do this is that the C standard library gives us some functions to do these basic common and useful conversions. So if we want to turn strings into integers, we get the function from the standard library called atoi. Can anyone tell me what that stands for? That was an inopportune yawn right there. Any guesses? Is anyone getting it online?
Is it ASCII to integer?
ASCII to integer, that's right. ASCII to integer. Now remember, this is important. It's only available if I import the standard library header file. So let's fix this program up. I hash include standard library. That gives me access to atoi, ASCII to integer. argv of 1, I'm planning, will be my number. But it's still a string. So what do I need to do? I need to create an integer called arg input, and I'm going to assign it argv of 1 passed into atoi. Now, is that the actual way that we use it? Yeah, I think so. So we take that ASCII input, we convert it to an integer, and I'm storing it in an integer variable. So what should I print on line 16? Was that a hand? No? What should I print on line 16? Arg input times 2. Yeah, exactly right. Exactly right. Yeah. All right, let's check if it worked. Look at that. So we take some ASCII, we convert it to an integer, and we print it out. Now, that's very powerful. Who agrees? Pretty useful. Whenever you're dealing with user input, values from the terminal, and data conversions, the hairs on your neck should stand up, and you should start beating with sweat. So why? Why should you get stressed out? You're like, we're so chill. Nothing gets it. Why should you get worried here? Think about it. What's going to happen here? I mean, it's going to do its best to turn this ASCII representation of the literal, of the values in memory, but it's just not going to work correctly. So you need to be careful. That's why you should get stressed. You need to be careful, because users will do crazy, stupid things, you will do crazy, stupid things, and the conversion functions will just do their best, which is not that good, really. So you might need to do things like check that the value you're trying to convert is convertible. And there's different functions for that. I can't remember it off the top of my head. What's the standard library function to check if an ASCII character is convertible to an integer? I think it exists. Sorry? Is alpha numerical? Yeah, anyway, it's for reading at home. In this demo here, what Sasha did is got multiple integers passed in and summed them all up. So it's combining the loop and the Ascii to integer function. But it's all the same idea. Cool? Okay, it is almost break time. Are there any questions?
You know how you use the atoi? What happens if you just use one character? It still gives 0.
Say that again. One character where?
Instead of J, you
Oh.
just put J.
If I just put J here, yeah, it still gives me 0. Now, why might it do that? So I suppose what this would be doing, someone can check, is taking J and converting it. Well, it mustn't be converting it to the ASCII character of J, right? My admins, tutors, what would this be doing? So why does this get 0? It must be treating it like a string. Yeah. So atoi doesn't do an ASCII convert. No, yeah, that's right. So atoi doesn't do an ASCII conversion because if we look at an ASCII table, where's the number, say 2, the decimal 2, is not mapped to integer 2. So it can't do ASCII 2 to ASCII mapping. It's actually looking literally at the character printed and it has its own internal mapping, which J wouldn't be included. So everything else must just go to 0. Which is kind of stupid, because 0 is a legitimate integer. So why would it go to a legitimate value? It should just throw an error or something you would claim. But anyway, does that answer your question? Any more questions? We have 2 minutes of dead time before the break.
What's the most powerful application of this in this course?
What's the most powerful application of command line arguments in COMP1511? I don't know, we don't really use them, do we? Yeah, you get taught it. So this, I would say this is getting ready for 1521 and some exam questions that are on the extension side. It's an important topic. I think back when we used to teach in semesters, we did a bit more with command line arguments, but it's just, it's very useful to know how to write programs that can have arguments passed in.
I thought it'd be cooler if you can use these to make custom libraries.
Well, you can use these to make custom libraries, and you can do, I mean, there's many things you can do with it. It's just an important concept, so we cover it. All right, let's do a lecture break. Do we have Kahoots? I've got one though, don't I? So let's break. Let's break for, what do we do? 5 No idea if this Kahoot is going to align, by the way. How many people online? Like, how many people are watching the stream? 191? So we should have like 300 here, right? No? Does anyone need another second? No? Everyone's ready? For those of you online, don't look at the stream, look at your local Kahoot, of course. All right, let's go. Oh, look at this. This is relevant. What is the value of argc when the following program is run? How do I see your answer? You got it wrong. Oh no. So who said 0? Who put 0? You liars. You put 0. Anyone else? So who said 0? There's 63 of you. You're liars, you're liars. Why is it 1? Why is the answer 1? Sorry? It's got nothing to do with a space here. There's no space. The name of the program is passed in as the first argument. Therefore, there is 1 argument. Okay, which function is used to access command line arguments? Are you playing the Kahoot? Weak. Weak. Oh, that was well done. That was good. That was good. All right, we don't need to discuss that. How are command line arguments separated in argv? Yeah, with white space. Why did you think? Who thought it was with a comma? Anything worth elaborating? Yeah. Oh, we lost our streaker. All right. Which function is used to convert the characters taken off the command line into integers that you can perform maths with? I mean, we just did this. Very good. Okay. What is argv of 3 in this example? Running the program Zuko, Aang, Iroh, Toph. Yeah. Yeah, very good. If you said Aang or Toph, you're just off by 1. Remember, this is 0, this is 1, this is 2, this is 3, this is 4. So 3 would be Iroh. Sorry? yeah, that's asking for too much. Yeah, very good. It's in the standard library. Standard I/O is for standard input-output. This is not an input or output function, so it's in standard lib. All right, and last question, I think. Jesus. Did you guess it? Good job. All right, it looks like people just guessed here. So you've got to consider you've got what, like 30 seconds. So who went through it line by line and tried to calculate it? And then did you run out of time? Yeah, so that's not probably going to work. What I would have done here is looked through the program and tried to see what it was doing and then quickly do that. So if we scan through, here's what's jumping out at me. We start at 1, not 0, so we're starting at the number 1. Obviously, we're ignoring the program string. We're looping through and summing up each value, and then down the end, we divide it by the number of integers passed in. So what's this function doing? Oh, God. No. Close. Then what? Average. It's just getting the average of the integers. You know, you sum up some numbers, you divide by the number of numbers, and you get the mean. Oh, God. Am I at you, Sid? Oh, kidding. Oh, kidding. And then, so what I would have done is quickly tried to average out those numbers in my head. And you can see it's somewhere, you got 2 1s here, 1 5, so it's just above the middle number, basically, 2.6. Did anyone do that? Who can average that fast? What's the average of 1, 2, 3? Sorry, I should have laughed. At least you're honest. That's good. Anyone in the room? You? Is that you? Oh, no. What? You're fourth? Oh, so you lost on time. Yeah, well. Is anyone here? Who are you? Who? 1. Gentle Pelican. Good job. Rocky Emu? No? Sturdy Griffin? All right. Did anyone learn something? That's all that matters. Untrue. All right. All right, quiet down. So who reads those Reddit posts where they're like, week 2, they're like, COMP1511 is really fun, and then week 5, they're like, holy shit, this was a trap. They were waiting for census. I say that all the time. It's very funny. I think this will be one of those moments, maybe. So basically, for the last 45 minutes. I'm going to attempt, because it's been actually quite a few terms since I've written any C, to write a program with you that takes you through the types of things you need to do in assignment 1. So it's probably a good idea to pay attention. And the way I like to do this is I'll try and write the code at a pace that even a UCID student could follow along with. So if you've got your laptop in front of you, maybe try and write alongside and compile and go through it too, so you go through the process. So we might be a little slower, but it means you can follow along. If you can't or don't follow along, that's also fine, because you can go back and watch the video. All right, so Sasha has written this program, and obviously I didn't write the problem, so I actually have no... In fact, this is quite good, because I'm exactly in your shoes. I've literally never seen this. I was told I'm doing the lecture like at midnight last night. So having come back from my time in the States, I was busy consistently trying to find churros. Why not make a program that we can use to bring a few concepts together? So we are a player navigating a 2-dimensional grid, so a map, in search of churros while avoiding walls. I mean, typically a good thing. The game tracks our position. We can move in 4 directions. The objective is to collect all the churros on the board by reaching their locations. All right. So this is just a high-level overview of what we're trying to do. There's not really any technical detail here other than the general structure. So we can probably move along. We will get some initial user input to set up the map. So you asked earlier, are we going to use command line arguments? I mean, this might be one place that can come into effect. So we're going to be told the location of the churros, the location of the walls, and the initial player's location. So a few things there. We will update the map with these details. We will keep on getting user input. So we will get user input using WASD keys to move around our 2-dimensional grid, our player. And we keep going until we find a churro. Once we find a churro, we collect the churro and then collect all the churros. You will allow yourself a break and to give up finding churros by pressing Control-G. Okay, so that's how we end our program. Cool? All right, we have some starter code. Fantastic. We have the Initialise Map Function, the Print Map Function, and the Print Location Function. Now, who's looked at the assignment 1? Did you get starter code? Yeah, so same sort of idea here. We're not going to totally throw you in the deep end, because it would take you a long time to kind of really get started. All right, so first things first probably, let's find our starter code. I mean, that's not our starter code. So did I copy the wrong thing maybe? Maybe this looks like my starter code from last time I taught. Right? Is the starter code on the course site? Whoops. Yeah, this is my code. Okay, give me a second. Oh, I'm screen sharing it. That's fine. That's fine. Nothing here is too bad. So where? That's okay. So where is the starter code from Sasha's? Can I do? Yeah, that's what I did wrong, I think. Bree, can you get me Sasha's public directory? Or someone? Sorry? On Teams? Sure. Can you go to a break screen, John? Oh, you've done it? Great. You sure that's correct? That's mine, isn't it? Yeah, that's mine. What's Sasha's? I thought, yeah, that's what we needed. Okay. So why don't we do copy? It's not a file or directory? Are you sure that's correct? Sorry? Yeah, that's what I'm using. I guess I need to. Oh, it's probably. Yeah, I got it. Okay, we're back. You can resume. All right. So churros. Where's my slide? Okay. We get some starter code, initialize map, print map, and print location. Let's get rid of this. So we get this initialize map function, okay? What are the parameters passed to it? Guys, keep the noise down. What's the parameters passed to the initialize map function? Who's speaking? Sorry, I can't. What are you saying?
Yeah, the array, it's an array of struct.
It's a two-dimensional array of the struct location. So let's have a look at location. Location is a struct that's got a tile, enum. So each location can either be empty or a wall or a churro or a trap or a teleport or a player or something like that. And a player action. Whoops. We also get print map. Print map's pretty simple. It loops through each of the elements in the two-dimensional array and it prints what it finds there. We have a print location function which does that handy work of telling us what actually happens there. and we can see what's there. And we have this sort of mapping so wall will be a hash, trap will be an exclamation mark, teleport will be a T, for example. And we have this print location function, which is the one we just looked at. We had a look at the enums that we get. So the enums represent what could be at a particular tile. And we had a look at that overall location struct. So do we see the similarities to assignment 1? Pretty obvious? All right. We can visualize. Now, it's great that this slide is here because I think this is the most important thing about tackling something like assignment 1 or anything with a data structure that's complex. Visualizing it is the most important thing you can do. So what I do is I get like a notepad out and I will just draw how I'm imagining the data structure. So what we have here, because it's a two-dimensional data structure, are the keys or the indices for each element. What this lets you do is get your head around, is the 0 increasing in the x direction, the y direction, which element is it, for example? So as the x index increases, that we can see is the second element. So 4, 5, 6, 7. As it increases in the y direction, it's the first element. So it's yx. Right, so is this helpful for getting an understanding of this grid and how to access the individual elements? Because each element, right, yx, rows, columns, stores what data type? Let's just repeat it. What's the data type at each element? A struct location, that's right. So that means anything in struct location is being stored, or there is enough memory at each element to store 2 enums, title and the player action. Cool? Following? Some thumbs up. So here here's a good example of how we actually access each element. So map of 4, 0, so the 4th row, the 0th column. The tile in this case is being is being checked to be empty, and there's no player action there. Okay. So let's compile and run the program as it is. Now if I look at main, where does it scans in. It scans in. Okay, so we get to build it ourselves. So GCC churros out to churros. I'll run churros. Okay, we get asked, where are we? So we need to enter the row and the column. So let's just say 1. I think we do it like this. How many churros would we like to place? Let's just place 1 churro for now. How's that? And where is the churro? So let's do it. Can I have the whiteboard marker, John? Or whoever had it? Who said computer scientists weren't athletic? Oh, I didn't need that. So if I've got a grid, hopefully you can all see this. Do we have a better marker by any chance? Okay, that's enough for now. Let's see. Here we go. Can you see this, everyone? That's better. Remember, we've got row, col. Is that right? So I place myself at 1, 1. So where am I? Where's the player? One, yeah, I mean, it's kind of a stupid question. So there's the player. I'm here. Let's decide where we want to put the, what was that? Let's decide where we want to put the churro. So let's not just randomly place it somewhere. Let's try and be intentional to see that we have an understanding of the data structure. So what if we want to put the churro, do we want to try putting it here? So what two integers do I need to type into the scanf? Yeah, 1, 3. Row, column. That's right. So 1, 3 will be row 1, column 3. This allows us to validate that everything is mapped correctly, because when we see it, when we call print map, we will get an understanding that the code is matching up to our understanding. How many walls would we like to place? Do you want to just now also just say one wall at 0, 0, just to get going? Okay, and then our game gets printed. Does this map over to what we expected? And we put the wall here. Is that correct? Yeah, I used the wrong character for the player, so that should be an S. And the churro is what? C. Oh, and of course, the game board is bigger. But everything's working correctly, so that's good. So that was important, right? You might think that maybe that was a waste of time, or that you just want to get writing code. But many, many times when you start a project or a program, especially with existing code, you know, it's so easy that the column and the row are flipped and your mapping is flipped. And then you just come into problems later on. So running through this is very important. All right, we can move around. So if I go D, I move to the left, right? I collected a churro. Nice. So that's all working correctly. Check out the style guide. Was that the complete code that I got access to? I mean, everything's working. What was I meant to do? Okay, well, why don't we delete stuff and just write stuff. So let's move. What's a good function to delete? This one, place churros? Yeah. We can leave, maybe we can leave check validity or something. Sorry? Yeah, okay, good idea. Let me just put it here. Maybe let's start actually with Initialise Map. Yeah, but we got to write something anyway, and that's all there. So, all right. Let's have a look at writing, just for an example to get us started, the Initialise Map function. So this is really important anytime we're dealing with a data structure, is to what we call zero out all the data. So in this case, we have a two-dimensional map of locations. Before we have any values to place into our map, it's not good behavior to leave it all as default memory, because it will be whatever was in that two-dimensional grid previously in memory. So what we want to do here is access every single element in this two-dimensional grid and default value assign the two enums in the struct. All right? So this gets us going with iterating through our map, for example. So we have a two-dimensional grid of the data type struct location, and it's called map. So the very first thing I want to do is, how do I loop through every element in the grid? You, I think I saw first. A nested loop, that's really good. So we know we'll have a for loop, and we know we'll have a for loop. Yeah? Because we need to loop through either the columns or the rows and then loop through each element in that first array. There was another hand down here? No? How do we know how many times we need to loop? AKA, how do we know how big or how many columns and rows we have? Right, because we have this problem, C programs don't know the length of their arrays. So there's two common ways that we can know this. One, we somehow store that integer in the data structure. But in our programs, typically, it's set with this hash define. So how many times do I have to loop here? What, but do I type 8? Or what do I type here? I don't want to type 8. I type the what? The macro. Is that what you said? No, that's not what you said. What did you say? Map rows. That's okay. That sounds a lot like macro, which is what this is. So map row is correct. Yeah, that's correct. Map rows, correct. Yeah. So this will loop through the rows. I guess, do we use row here? Is that what you've been doing? Something like this. Now I get these two variables, row and col, which represent the indices, the axes. So can someone just tell me what I type to access the map at the position each time in the loop? That's right. This will represent, in the loops, each individual element. Now what's the goal of this function, initialize map? Now that's an example of a really terrible comment because it tells you absolutely nothing in addition to what the name of the function told me. So it should set each map row col to, now if we look at our struct location, we've got an enum tile and an enum player action. If we look at those, what should the default tile, what does it make sense to be? Empty. And what does the default player action make sense to be? Nothing. So you can see if we relied on automatic zeroing, player action would actually be initialized to move up because it's the 0th element in the enum. So that's why initializing is so important. So let's just do that. So each element is a struct. The struct contains two things, the tile and the location, so action. So the tile we said should be what? Empty. And the player action should be what? Nothing. And that initializes our grid. Let's test that works. Let's put us at 0, 0. Let's add 0 walls, or 0, 0 sorry. And you can see that's roughly working correctly. Sorry? I can move out of bounds? How do you mean? Oh, yeah, it is letting me do it at the moment, but maybe that's a bug we can fix. Just out of curiosity, if we didn't have these two lines, let's see what would happen. Look at that. right? Now, if you do this with DCC, I think you'll get different behavior, by the way. So you should try this without initializing. DCC, I'm pretty sure zeroes out memory, but it'll still be incorrect because it'll keep telling you to move up, I think. Okay. So doing something simple again like that is useful because it gets you practicing looping through. So let's do something a little bit more sophisticated now. I think maybe a good one is something like check validity. Let's delete it. And let's think about what we're doing here. So a sanity checker, a validity checker, anytime we're dealing with something like a data structure like this, is incredibly important. What does it do? It makes sure that we don't assign a churro or a player, for example, off the grid. Once we start doing something like that, we're in trouble. We want to make sure that our struct location is within the bounds of the map. Right? What this really means is row should be greater than 0, and, because let's think about it, right? Where's that marker? The row if row is an integer, and so is col, and if my player starts here and I move left 2 times, is there anything with the data type integer stopping me from getting off the map? No, because integers can go negative. So we need to stop that from happening in the first place. So what I should be checking is that I don't go less than this position, which is 0. And I don't go greater than the end of my map, which would be map rows. Right, we've got to be careful not to use the integer 8 or anything like that. Let me just check something quickly. All right. Okay. Now, what are we passed in to this function? This is really important. We're given the map itself, which is struct location map 2-dimensional array. That's the third parameter. We're also given 2 integers. This is the row and column location that's something we're checking that something may happen at. We don't know what will happen. We don't know if we're moving there. We don't know if we're trying to assign something to that tile. But this is the spot that's about to occur. Something's about to occur. So we're getting a position, row and col. We want to check, is it in the bounds of the grid, of the map? So when I just said that out loud, is it within the bounds of the map? That gives us a hint here as to the type of code that we're writing here. We also get a hint that it returns an integer. So this function should return 1 or 0, true or false, for whether or not it's a valid position on our map. So what type of sort of artifact do we want to be writing in this check validity function? Like, are we looping through something? What are we doing? It's an if statement. We're asking a question, is this position a valid position? Does that make sense? So we're going to have roughly, if row fits and col fits, return what? Or what just makes sense logically? Would we return true or false? It's not made clear, but true is always a truthy value. So if something fits, it's going to be true. It's valid. The function title is check validity, right? Is valid would be true, just by intuition. And even if it were wrong, it would be easy to fix later. Is valid was probably a better function name. Yeah. Check validity doesn't sound like it returns anything. I do agree with you there. Yeah. Whoops. So we would return 1 in the case that they're both within bounds. All right, so let's go about typing this. Let's do row first. So what's the lower bounds of row? 0. Okay. So there's a few ways we can structure this. Let's do something quite simple. If row is less than 0, is that okay or a problem? It's a problem? I agree. Or the row is greater than map rows. So this is an invalid case. Agreed? If either of those things are true, we can return false, because that's invalid. Yeah, we will deal with that in a second. Yeah, I was going to get to that. So we're saying we're just looking at the row. If the row is below 0 or greater than map rows, we're saying no, this is not valid, right? What else do we need to add here? Okay, 2 people have spotted it now, so let's check this. This is something that always throws a lot of people off. It's another example of an off by 1 error. So map rows is 8. Let's in this case say 1, 2, 3, 4. Well, actually, how is it structured? So I think map rows is 8, yeah, and we have 1, 2, 3, 4, 5, 6, 7, 8 rows, which means the index is from 0 to 7. So the valid indexes are 0 to 7, but map rows is 8. Whoops. So is 8 a valid index? No. 8 is invalid. So actually, I think it's fine. 8 is invalid. Is 7 invalid? So 8 is invalid. Sorry, yeah, you're right. So you're all right. Yeah. So because 8 is invalid because it goes up to 7, if it's equal to map rows, that's a problem too. Yeah. Thank you. Who's happy with this? Yep. All right. Now we just need to basically do the exact same thing for column. Map columns. So if either of the columns are out of bounds, we return 0. And now this is a completely good function because we can just say, well, if we get to this point, we didn't determine that we're out of bounds with the row. We didn't determine that we're out of bounds with the column. Therefore, we must be what? In bounds, which means we return true. Now, there's a question here, but what's your question? That's okay. So if we actually look at the code that was in the starter code that Sasha wrote, we can see that can we merge these 2 checks into a single statement? Yes. Who thinks we can do that? Okay. Who thinks it's a good idea? Okay, I disagree with you all if you said yes. If I look at this, if I glance at this code, is it super obvious what it's doing? You check the rows, you check the cols, and then you return true in the end. If we glance at this, now it's not to say this code is incorrect, but if you glance at it, which is more glanceable? You tell me. Sorry? if I new lined this, okay, but I don't have, there's no comments in either. What? Okay. Right? I would argue that that's a bit more glanceable because you're breaking down the multiple conditions. So all I'm trying to say is there is absolutely nothing wrong with breaking things down so that when you're deep into assignment 1 and you're stressed and struggling and you're going back to check if something works, this is a little bit more traceable. We're not increasing the total depth, right? The maximum depth is 1 scope in from 1 if statement. It's the same here. Oh, we also need to check that it's not a wall, by the way. So I didn't do that. So this is checking that the bounds are correct. So we're still doing that. If the bounds are correct, we need to check that there's no wall there. So this must be checking the validity if the player can be there. So where is our case for that we're in the bounds? What line? 132. Yeah, very good. So if we get to line 132, we're within the bounds, and that's where we want to check that it's not a wall. So actually what we can just return here is return map of row col. Now if it's a wall, so I think we can do that. What's wrong with that? Oh, sorry, tile. Maybe that's more fitting with what I did. So yeah, this will be fine, or you can say if it's equal to a wall, right? Return 0. Yeah, maybe that's better. Whoops. Don't forget your semicolon there. Cool? Do we have any questions on the process for writing something like this? Any good comments online? So there was a comment about including standard bool and using the keyword true or false. I agree that would probably be a bit nicer. But this is just, it's the same thing. Yeah. Question?
Why do you do return in every if statement? You could use a
Okay, so the question was, why do I have 3 return 0 statements? Why not have I guess you could, what you're saying is, like I could do something like int result, whoops, right? And then you would say result is equal to 0 here, result is equal to 0 here, result is equal to 0 here, result is equal to 1 here, and then we return result. Is that better? Maybe, because you've only got 1 return statement. I could foresee something going wrong, which is that the initialization of result is a valid return statement. So if the complexity of this function changes and you have an error in one of your statements, you wouldn't actually know that you're exiting intentionally. Does that make sense? Well, let's say that in the future I say that, well, there's not just walls, there's now some other thing, there's some other barrier. So I, add some barrier, and I have to do another if statement here, and I forget to have result is 0. What would this return if I hit that case?
0.
Right, because 0 is valid. Does that make sense? It's fine. It's an acceptable solution. Now we're getting maybe more into preference. Sorry? Well, it might not if you had else, if-else statements. Yeah, that's actually another point. You'd have to make these else-ifs. Otherwise, you could double-check things. See, yeah, it gets. I think this is called guarding. When we return, we're guarding because it's like you can't continue because you're returning, and it makes it cleaner because less code can run. Okay, I think that's where we're going to leave it. If you've got any more questions about the code, you can come up and ask, of course. On Wednesday, I think you're back to regularly scheduled programming, so you'll have Sasha delivering the... Tuesday, tomorrow, sorry. You'll have Sasha delivering it online.